Okay, so here we're looking at graphing transformations. So when you're graphing transformations, the first thing is to make sure you know how to graph the original graph, the parent graph. So the original standard quadratic function is this shape here, like this U, right? So we know that when we look at the function x plus 5 squared minus 7, we know it's a parabola, so we already know the shape. So then we use our rules to help us identify the initial point, meaning how the body shifts so that we can see where this graph is going to relocate. So the horizontal shift is 5 units, and it's moving 5 units to the left, and that's because of our transformation rules, which says if there's anything being added to the x component in the function, it shifts c units left. So we know it's 5 units left, which 5 units to the left is at the negative 5. Then we have negative 7, and so we know from that rule, f of x minus a c means it's going to shift c units down. So the vertical shift is 7 units down. So negative 7. So negative 5 down to negative 7 would put our initial point there. Then we use a t-table in order to get additional points. So remember, I know that this graph should look like this shape here. So I know where my body is, which on here it's at 0, 0. And over here it's at negative 5, negative 7. So what I'm going to do is I need to get a point on the left side and a point on the right side. So I'm going to just use a number that's on the left side of what? Of negative 5. So I'm going to just use negative 7. So what do we have to do? We actually have to substitute it in and simplify it to see what we get. So we get negative 3. So negative 7, negative 3. Then I'm going to pick a number on the other side of the x. So at negative 5, I'm going to pick negative 4. So I get negative 6. So negative 4, negative 6. So what do I know? I know it should mimic what? The original parent. So if this is my body, I'm just going to draw my graph. Left arm, right arm. Right to your points, okay? And that's it. Make sure you have your ordered pairs. Make sure you know where your initial point is, and then you just draw your body out, your arms outside of that body location. All right. Next, we have the square root function. So the square root function we see is only a one-armed function. All right. So I have my initial point at 0, 0, and then the graph goes out to the right. So when we look at the actual graph, the function that is given to us for the transformation, the negative square root of x plus 2 minus 2. So my initial point is negative 2, negative 2. So I plot that. My horizontal shift is 2 units left. That's what makes it negative. 2 units down. That's what makes it negative. So now I just need to find another point so that I can figure out where my arm is going. So I'm going to just pick, it's a square root, so I need something that's going to come out as a perfect square. So I'm going to pick 2. Square root of 4 minus 2. 2 minus 2, 0. So 2 comma 0. It's negative. So this is negative 4. All right, so 2, negative 4 gives us that point there. So then we can just, and we're done. All right, so it's only one arm, so you really just need one extra point from the initial point. And this negative here outside lets me know that it should flip this upside down. So see how it's up. So then this flips it upside down because it reflects about the x-axis like the rule tells us it should.